Right, hello there. So this is a typical shapes slash calculus question. You'll find them peppered throughout the Leaving Cert. Usually paper one, usually section B. Okay, so they all follow the same tricks. So they're very easy kind of once you get the idea. Okay, so at the start here we have a right circular cone, and there's the hint, a right circular cone inscribed inside in a circle as shown. The sphere has a center of 0, okay, and the radius of 12. Okay, so that'll come into play in a few minutes. A is the vertex of the cone, and B is the point on the base of the cone that touches the sphere, and C is on the center of the cone. So they're giving us all the kind of the details. Okay, so basically B and C are on the circular face of the cone. In other words, the bit at the flat bit, for want of a better word, is the apex of the cone, and the distance from A to C is the height of the cone. That's what they're really saying. O really refers just to the circle, or in this case, the sphere. And the first of all thing they want to find is find BC, which is the radius of the cone. Okay, so the best thing to do here with all these type of questions is extract the problem, extract the shape that you need. And what I see is they told us a right circular cone. So the shape I need to kind of extract is the right angle that's living inside this cone. And you can see it, it's ABC. It's the right angle ABC. Okay, so you can draw it again. So if you think about it, we have A, B, C, and that's your little right angle that lives inside, okay? And we're just really trying to find the length of BC, okay? Just that fella there, okay? So in order to do that, we need to put in the information that we know, okay? So we know that the sphere has a radius of 12. So let's put that in. So a radius always goes from the center to the edge. So I can technically put in a different color this line here. Okay, and that is 12. Okay, so they tell us that OC is X. Okay, and they want us to find BC in terms of X. So let's find BC in terms of X. So BC is one of the sides, but it's not the longest side, because the longest side is 12. Why? Because the right angle is in here, and that longest side is opposite the right angle. So really it's going to be 12 squared minus the x squared is going to be equal to BC squared, for want of a better word. Okay, so again, what are we going to do? We're going to square root both sides to get rid. So that means that BC, the length of BC, is going to be equal to the square root of 12 squared minus x squared, or if you want to be technical about it, it's equal to the square root. I hope I have enough space here. I'll move that over. It's going to be the square root of 144 minus x squared. Or you could actually get rid of the square root and just put it to the power of a half, you know. But listen, any of those answers are technically correct, okay? So that's the first bit done. The second bit, show that the volume of the cone is equal to 4 over 3 times this squared times this. So you're thinking, what's going on here altogether? Okay, so I suppose the first thing you do is you get into your log tables, because this is all around your log tables, and you figure out that the volume of a cone is 1/3 pi r squared h, where r is the radius and h is the height of the cone. And obviously in our case, the height of the cone is from A to C. So let's put in what we know. Okay, so that means that the volume of the cone is going to be equal to 1/3 by pi, which we know, by the radius squared. Okay, so the radius squared is BC, so that's BC squared by the height. Now, what is the height? Okay, well, we know for sure that the distance from there to there is 12. That's also distance, by the way, and you can spot what's going to happen here, from there to there, because it's from the center of the sphere to the top or the bottom or any other point along its surface. So that distance is 12 and that distance is x. So the distance from A to C is actually I'm going to put it in as AC, and then I'm going to show you this is from A to C. But I know that the distance from A to C is equal to 12 plus x. Okay, so this is what we're going to do. We're going to pop it all in. So let's pop it all in together. Equals 1/3 pi. BC we've already worked out as root 144 minus x squared, and AC we've worked out as 12 plus x. So that's 1/3 pi r squared h. Okay, so let's tidy this up because you can see we need to get it to be that form. Okay, so the 1/3 pi, that's that bit there, so let's make that true. That's equal to pi over 3 is 1/3 pi, so I've just multiplied those two bits together to get that sorted. Because I'm squaring a square root, I can get rid of the square root. Okay, so that's really 144 minus x squared times 12 plus x. Now let's be smart about this. You could multiply that out and you'd be crazy. What you can see here, if you look at it carefully, is the difference of two squares. That's equal to pi over 3 times 12 plus x by 12 minus x by another 12 plus x. And as you can see, the original one was 12 plus x squared, so I'm just going to pop these two back together. That's just pi over 3 by 12 plus x squared, that's those two, and then I'm just tagging on the 12 minus x, and that is what they wanted at the start. Okay, now hence find the maximum volume of the cone in terms, here comes the calculus, maximum value or minimum value, anything to do maximum or minimum, there's usually going to be some type of calculus involved when they mention those things, especially in this type of question. So really what you need is you need to find a formula, nudge nudge wink wink, a formula that you can differentiate. And usually they're pre-prepared it, either it's somewhere up here or you've been forced to make that formula. So really what I'm going to be doing is I have my volume of my cone. Okay, so I'm going to pop it down here. What is it? 4 over 3. Sorry, pi over 3, 4 over 3. I'm thinking of a sphere. Pi over 3. And we've got 12 plus x squared by 12 plus by 12 minus x. Sorry. So there's my original volume. And then all we're going to do is we're just going to differentiate it. We're going to differentiate in terms of dV dx. Why dV dx? Because we're wanting the volume to vary based on the only variable that we have, which is x. So it makes sense that we're going to do a dV dx. Now, you could, if you wanted to, dy dx this thing as it is. But my advice would be, even though you've gone to all the trouble of making it look like that, I'd unmake it. I'd multiply it out as much as humanly possible and then dy dx it. Why? Because it'll just make it a little bit easier. Okay? Because you don't want to go down the route of having to dy dx 3 different bits at the same time. It's just hassle. So that's pi over 3 times 12 plus x by 12 plus x by 12 minus x. So that's equal to pi over 3 times, well, that's going to be, what's that going to be? Well, I know that those two together, that's 144 minus x squared times 12 plus x. And then we're just going to multiply these two out, pi over 3. And so we've got 144 times 12. 144 times 12, which is 1728. That's those two minus x cubed. So that's those two. And then it's going to be 144x and minus 12x squared. So you got a nice cubic here. Look, it's a lovely little cubic. And the beauty is, because everything in the cubic is separated, when I differentiate this as a u by a v, it's going to be very easy. So dv dx is, this is a u by a v, that's a u, and this whole thing in the bracket is v. But I've taught you the trick that if you have a u that's a constant, then it's really just going to be pi over 3 u by dv. That's really all it is. So dv in this fella is just 144 minus 3x squared minus 24x. That's it done. Okay, now you've divided. But where's the maximum bit coming on? Okay, it's a maximum when your curve, your function that you get from dy dx, and when you're doing your calculus, the whole point is to create some type of function that generates a slope. And when a slope equals 0, it's at a max or a min. So that's going to make this fella 0, and we're going to solve it. Okay, so we're going to let pi over 3 times 144 minus 3x squared minus 24, this solves, I can see it already, is equal to 0. So listen, because you've got something multiplied by, that's equal to 0, and this is also equal to 0. So let's solve this fella in here. Okay, so you can use your minus b to solve it, but I can see already that everything there, I think, there's 144, yeah, they all divide by 3. So that's really going to be x squared, 8x, and what's 144 divided by 3? 48. So you're really going to be doing x squared plus 8x minus 48 equal to 0. Bracket, 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 x, I hope I haven't lost any space here. Why are we looking at 12 and a 4, 12 and a 4. We want a positive 8, so that means a positive and a negative. So x is equal to 4, or x is equal to minus 12. And you can't have x equal to minus 12. Why? Because we're dealing with three-dimensional space, and you can't have negative distance. And don't start shouting at the screen, yes you can. You know, I listen to Einstein and, you know, all this type of stuff. No, listen, we're doing maths here. It's not negative. It's going to be the bloody 4. Okay? Now, because it's a 4, you know, you can go in and check, put the 4 back in, pop the 4 back in up here. Okay? So at x equal to 4, listen, I'm just going to do this on the calculator. Okay, 12 plus 4 is 16, so 16 squared times 8 divided by 3. So we've got 20, 48, and then multiply it by the pi. So that's going to give me 20, 48 pi over 3. And we have units, centimeters cubed. Don't forget the bloody units. Okay, so that's the maximum volume.